So let's see this question 2. This is about quadratic again. So they said a piece of wire 12 cm long is cut into 2 pieces. One piece is used to form a square shape and the other is a rectangular shape in which the length is twice its width. Okay, so that means imagine that you have a piece of wire which is like this 12 cm long. So you cut it into a square shape and then another to a rectangle. So the rectangles where we have the length is twice its width. Okay, now let's see part A. Part A over here. If xcm is the side length of the square, okay, so that means this is x. Okay, let me write down first. X, 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 and x. Okay, write down the dimension of the rectangle in terms of x. Okay, so we need to write down the dimension. That means you have to write down the length and the width. That is the dimension. So what we can do here is first we have to know that the perimeter of the square is 4x. As you should be able to imagine, we have x plus x plus x plus x, that is 4x. So your wire is 12 cm, so 4x is used to form the square. And so imagine, let's say it's going to be like this. So part of the wire where the length is 4x, it is used to form the square. The remaining part of the wire, the length, which is 12 minus 4x, so it is used to form the rectangle. Okay, the rectangle. So we also know that the rectangle has, let's say, the length as 2y, the width as y. Okay, so now we need to find out the dimension. So we put it in this way. So 12 minus 4x, which is the remaining length of the wire, we use it to form the rectangle. So the rectangle consists of 4 sides, 2y plus 2y. This is the two lengths, and then y plus y, which is the width. So we add them up. So we get 2, 4, 6, 6y then. We get 6y. 12 minus 4x. Now after that, we have to find y in terms of x. So for this equation, I can see that it is possible to divide. Okay, divide. So let's say divide by 2. Divide by 2, I will get 6 minus 2x equal to 3y. So I will get 3y equal to this. So let's say I get y first. Y equal to 6 over 2, 6y, 6 over 3, 2y over 3. So I will get 2 minus 2 over 3y. X. This should be x. Should be x. Okay, y equal to 2 minus 2 over 3x. Okay, so this is the width. The width, as you can see here, the width is 2 minus 2 over 3x. The length, which is 2y, then it's going to be 4 minus 4 over 3x. So that is the length. Okay, now let's say dimensions. The dimension that I'm going to put is length by width. Okay, so my length is going to be 2y, right? So which is 4 minus 4 over 3x. And then my width is 2 minus 2 over 3x. Okay, so that is my dimension. And this is the answer for, yeah, this is A, part A. Okay, so 2A we have done. Now let's see B then. Formulate a rule for A, the combined area of the square and rectangle in cm square in terms of x. Okay, so let's do it at the side here, 2B. So A is the combined area. Okay, so for square, the area is just x by x. So which is x square. So x square for the area of square. For the rectangle, we just need to use the length multiplied with the width. So that means you take these two and multiply them. So we will get 4 minus 4 over 3x multiply with 2 minus 2 over 3x. So that will be the area of the rectangle. Okay, now let's say I simplified it. X squared, so I times this, and this. So 4 times 2 I get 8. 4 times that I get 8 over 3. Negative 4 over 3 x times 2 I get negative 8 over 3x, and positive 8 over 9x squared. Okay, so once I get this, so I just need to simplify it. I add up the x squared terms and I get 17 over 9x squared. Then I minus the 2x term over there. Then I get minus 16 over 3x plus 8. So this is the area in terms of x. Okay, now we look at the question again, part C. Determine the length of the two pieces if the sum of the areas is to be a minimum. Okay, so the area is a minimum. So we have a quadratic here. To find the minimum, we need to do completing the square. Okay, so to C, so we have to start with completing the square. And to do completing the square, we have to make sure the coefficient or the number in front of x squared is factorized out. Okay, so I need to factorize 17 over 9. So the first term, after factorizing 17 over 9, only x squared remain. For the second term, after factorizing 17 over 9, what remains? So basically we just need to divide. We take minus 16 over 3 divide by 17 over 9. 17 over 9. So we will get minus 48 over 17. And let's say for the third term, the 8, I just leave it there outside of the bracket. So I don't want to factorize it. Just leave it like that. And now let's continue. Okay, so we have this as our B. This is the B. So when you do completing the square, so we have to write back 17 over 9 x squared minus bx plus b over 2x, b over 2 square. So b over 2 is going to be minus 24 over 17 square minus negative 24 over 17 square, and then plus 8. Okay, so like that. And now we need to factorize the first 3 terms. So let's say before I factorize, I just put it in 24 over 17, I square it, 576 over 289 minus 576 over 289 plus A. Okay, that is the area, 17 over 9. Okay, so we need to factorize the first three terms. Okay, so of course you can just use calculator to factorize or just do manual. The manual way is going to be like this: x times x, you get x squared, and then you have to think of two numbers multiply each other and get to 576 over 289. So this is a bit 576 over 289. This is big values. Then after that, two numbers multiply to get this. What values are we going to use? We always use this, the one before you square. So we always use minus 24 over 17 minus 24 over 17. We cross multiply, and 24 over 17x minus 24 over 17x. Now you add them up, minus 48 over 17x. So we have to make sure we get the term in the middle. So this one must be the same with this one. So we have that, and that means our factorization works. Okay, so we get x minus 24 over 17 square. Okay, now after doing so for this one, what we need to do is, let's say I just write it back first. I don't want to do anything first. 289
okay,
plus 8. Okay, now I times this with this, and I times this with this. So I get 17 over 9. Okay, for this I have to use calculator. 17 over 9 multiply with these big fractions. So I get negative 64 over 17 plus 8. Okay, then minus 64 over 17 plus 8. So end up with positive 72 over 17. Okay, so we get this after completing the square. And now let's come back to the question again. So
okay,
they want us to determine the lengths of the two pieces. That means the square and the rectangle. If the sum of the area is to be minimum. The sum of area is to be minimum. Okay, so as you can see here, when it is minimum, if you take this value, we have to know that completing the square is to find the minimum. So this is the minimum. And when it's minimum, the x take what value? So we can find it out in this way. We let the bracket equal to 0. So x minus 24 over 17 equal to 0. And then x equal to 24 over 17. So we get this. This is the x value that make the area to be minimum. Okay, so this is one of the answer. Okay, as the question asks, want us to determine the length of the two pieces. Okay, so this is the length of the square when the sum of areas is minimum. Okay, so the other thing that we need to find is actually the length of the rectangle. So the length of the rectangle, which is 2y, okay, which is 2y. So we have to use this equation here, 2y equal to 4 minus 4 over 3x. Okay, so what happened then is, okay, let me write down first. 2y equal to 4 minus 4 over 3x. So the x value is 24 over 17. Okay, then we get 4 minus 4 over 3, then 24 over 17, then we get 36 over 17. Okay, so this is the answer also. This is the length of the rectangle when the sum of areas is minimum. Okay, so we finish off the whole question. Okay, it's a long question. Okay, now let's look at the second question. Water is pumped into an empty metal tank at a steady rate of 0.2 liters per minute. Okay, so imagine I draw out the water tank. This is the water tank. Okay, so water is going in at the rate of 0.2 liter per minute. Okay, so after that, after 1 hour, the depth of water in the tank is 5 cm. After 5 hours, the depth is 10 cm. Okay, so when the time is 1 hour, the depth 5 cm. When the time is 5 hours, the depth is 10 cm. Okay, so we look at A now. If the volume of water in the tank is V liters, when the depth is X cm, and there is a quadratic relationship between V and X, write down a rule which connect V and X. Okay, so I'm able to imagine that this water tank is not going to be a cylinder shape, most probably, as I see initially the depth increased quickly, but at the end the depth increased slowly. So maybe the water tank is going to be like that, for example. Okay, so where the depth increased quickly at the beginning, then after that increased slowly. As you can see, 5 hours 10 cm, 1 hour already 5 cm. So you can see the depth increased slowly at the end. So meaning that the water tank should be very big after they fill up a particular part. Okay, so now no matter how's the shape of the water tank, so we just need to solve it in this way. They say there is a quadratic relationship. Okay, so we just need to set up in.
You started lagging. I couldn't hear.
Oh.
So I couldn't hear the last part. You started lagging a lot, so you cut out.
Oh, okay. So what am I trying to say is, they said the V and the X has a quadratic relationship. So meaning that no matter what shape is the water tank, we just need to do it in this way. Form a quadratic equation. V equal to ax squared plus bx plus c. Just form a quadratic equation. And we have to find out a, b, and c. Okay, we have to find out A, B, and C by using the information over here. Okay, by using the information here. So let's see. Okay, the first information is after 1 hour. After 1 hour, the depth is 5 cm. So we need to find out the volume. Okay, so the volume, okay, we put it in this way. In 1 minute, the volume is 0.2 liter in 1 minute. Okay, so now for 1 hour, there are 60 minutes. 60 minutes. 60 minutes, I have to times 60. Times 60. So here I need to times 60 as well. So the volume is hence 0.2 times 60. So which is 12 liter. 12 liter. So because of that, I know when x is when the time is 1 hour or 60 minutes, the volume is 12. Okay, the volume is 12. Okay. So I'm going to put here V is going to be 12. The depth or the x is going to be 5. So the depth here I label with x. The x is equal to 5. The volume is 12 liter. Okay. Now that's the first part. The second part is 5 hours. So we know 5 hours is basically 300 minutes.
60, yeah. So 60 times 5.
60 times 5, yes. 300 minutes at the end. Okay, 60 times 5. So if we times 5 on the left, so we need to times 5 on the right. So the volume is 12 times 5, which is 60 liter. 60 liter. So, and we applied it here. After 5 hours, the depth, which is the x is going to be 10 cm. The volume is going to be 60 liter. Okay, so in fact we also have one more information. Water is pumped into an empty metal tank. Okay, so meaning that at the beginning, 0 hour, since it is empty, the x is going to be 0 cm, the depth is 0, the volume is also 0 because it's empty. So we have actually 3 information. And if I use the first information here, v equal to 0 and x equal to 0, so I will get, imagine v equal to 0, x equal to 0. I substitute 0 over here, here, and here, then I will get 0 equal to a0 square plus b0 plus c. 0 equal to 0 plus 0 plus c. I will get c equal to 0. I get c first. The value of c is 0. Okay, so because of that, our quadratic equation become ax squared plus bx. C is 0. No need to write it down anymore. Okay, so we have this simplified version with only a and b to be found. Okay, now we have to use the second information. X is 5, v is 12. So I write down x is 5, v is 12. So 12 equal to a 5 square, b 5. 12 equal to 25a, 5b. Okay, and I just leave it like that first. Okay, now we use the third information. X is 10, v is 60. So x is 10, v is 60. Okay, so 60 equal to a 10 square plus b 10. Then we get 60 equal to 100a plus 10B. Okay, now in order to continue this, okay, let's say what we need to do is we have to find A and B, by the way. We have to do simultaneous equation. So let's say I use substitution. Okay, so I divide by 10 first. I divide by 10. 6 equal to 10A plus B. B equal to 6 minus 10A. Okay, I have equation 1, equation 2. So I need to do simultaneous equation by using substitution. So I do substitution of 2 into 1. So imagine something like this. I substitute this over here to replace the B with 6 minus 10A. So I will get 12 equal to 25A plus 5, 6 minus 10A. So I need to count the values of A, of course. So I just continue doing this. Multiply with 5, so I get 30 minus 50A, 12. Okay, so then I just need to solve the equation. So 25A minus 50A, I get negative 25A plus 30. Okay, then I shift the 25, the negative 25A, I shift to the left. So I get positive 25A, 30 minus 12. So A equal to 18 over 25. Okay, that's the values of A. Now I use equation B to find out, I use equation 2 to find out the value of B. 6 minus 10A. Then I just need to press calculator for this. 6 minus 10 times 18 over 25. So I get negative 6 over 5. Okay, so I have A and B. So what to do then is, I already get the quadratic equation in this form. So as you can see, which is this one, V equal to AX squared plus BX. We know A now, 18 over 25. So I just write it down, 18 over 25 x squared minus 6 over 5 x. So this is the quadratic relationship. Okay, so that is what they ask in part A. Okay, so in part A, we already get this. Now in B, it is known that the maximum possible depth of water in the tank is 20 cm. Okay, maximum possible depth. Okay, and then 20 cm. For how long from the beginning can water be pumped into the tank? Okay, 20 cm. So let's see. This is our quadratic relation, and the question said the x is going to be 20. X is going to be 20. Okay, so let's do it here. Part B. Given x equal to 20. Okay, we use 20 to find the volume first. To find the volume, okay, I substitute 20 here and here. So V equal to 18 over 25, 20 squared, 6 over 5, 20. Okay, then I count it. 18 over 25, 20 squared, 6 over 5 times 20. So I get 264 liter. 264 liter. Okay, so this is the volume of water And now the question asks, for how long from the beginning can water be pumped into the tank? Okay, so you see the water pump at this rate, 1 minute 0.2 liter. So okay, the rate, let me write down again. The rate is 0.2 liter per minute. So that means 1 minute, 1 minute 0.2 liter.
Okay.
Now they ask how long. So there are a few ways to handle this. One of the way is just do it manually. Is, for example, like okay, at time 5 on both sides. At time 5. So 5 minutes will make it to 0.2 times 5 is 1 liter. So it takes 5 minutes to get 1 liters of water. Okay, now I have 264 liters. Okay, so I need to times 264. 264. So I times 264 on both sides. So of course here I get 264 liter. And the left hand side, 264 times 5, I get 1320 minutes. So it takes 1320 minutes to get 264 liter. Okay, so that is the answer of the question actually, as the question asks for how long. Okay, 1320 minutes. So that is the time. Okay, so the time is going to be 1320 minutes, and let's say I change it to hour, so I have to divide by 60, so it takes 22 hours to fill up the water tank. 22 hours. Okay, so this is the manual way to do it. So of course if you are not using this manual way, there is a way which is formula. So the formula is going to be like this. If you are not using this way, so let's say I put it as method 2.
Okay.
Yeah, there's a formula which is known as rate equal to volume over time. So let's say I put symbol 1. This is V, this is T. This one rate, I call it R lah, let's say. So I have R rate equal to volume over time. Okay, now we have the rate, which is 0.2 liter per minute. So R is 0.2. We have volume is 264. Okay, so we write here 264. We need to look for the time, so time is 264 divided by 0.2. 264 divided by 0.2, we get 1320 minutes. As you can see, we get back the same answer. And then let's say I divide by 60. Divide by 60 to get the time in hours. So I will get 22 hours. So you get the same answer no matter you use the first way or the second way. So it will be the same answer. Okay, so I have done this question. Okay, now the figure shows a section's view of a freeway embankment to be built across a flood-prone river flat. The height of the embankment is X meter, and the width at the top is 90 meters. So this is the width. Find the formula in terms of X. in terms of x. For V, the volume of Earth in meter cube required to build a 120 meter length of freeway embankment. Okay, so that means this thing is going to be having a length of 120 meter. So try to imagine it's going to be a prism shaped in this way, something like this, prism shape. Okay, something like this. Try to imagine. Okay, this is the embankment. The length is 120 meter. So we want to find the volume then, the volume of this prism. Basically the volume, right, is, okay, I write down the formula first. So as this is prism, so volume is equal to cross sectional area multiplied with length. That's the volume. So the cross sectional area that I wrote is actually this area. I just point it here, this one, the area of the trapeziums. Okay, area of the trapezium. So let me write down first. It's actually the area of trapezium multiply with the length. Okay, now let us work it out. So we have to know the area of trapeziums. The formula is 1/2 multiply with the sum of the parallel sides. That means you have to find out this and this one. I have to find out that. Okay, so the problem is we have the 90 given, but we don't have the length at the bottom. We don't have this value, so we need to work it out first before we come back to this. Okay, so to work it out for this part, so what we can do is I just add 2 vertical lines. Then I know that this is going to be 90. This is going to be 90 meter, same as above, as these are the vertical lines, so they form a rectangle. So if this is 90 meter, this is going to be 90 meter as well. Okay, then when I look at this rectangle, so I understand that if this is 45 degree, this is 90 degree, this is going to be 45 degree also. Yeah, 45 degree. And end up with this is an isosceles triangle, meaning that this and this are same length. Okay, and we know that this is x meter, as it is given here, it is x meter. So if this is x meter, then this is going to be x meter as well. So I write it down. This is x meter. So this side will be similar, as the triangle looks the same only. So this is x meter also. So altogether, the whole base will have, the whole base here will be 90 plus 2x. 90 plus 2x meter. That's the length of the bottom. Okay, now let's come back to our area of trapezium just now. So what I said is 1/2 multiply with the sum of the parallel sides. So the first side is 90. Okay, let's say I use red color, 90. The second one is 90 plus 2x. So I add up the 2 parallel sides basically, which is 90 plus this one. Okay, then multiply with the height. The height is x, the x meter. Okay, so that is this whole thing, right? This whole thing is area of trapezium. The one that I put in square bracket is the area of trapezium. Then I have to multiply with the length, which is 120 meter. 120 meter. Okay, so just for your reference, I write the formula of trapezium here. If later when you look back at the working, you feel like cannot process the information, then you see the formula here. Here to here is A, let's say. Here to here is B, let's say, and here is the height. So the area of trapezium is basically 1 over 2 A plus B multiplied with the height. So it's actually this formula where I applied it over here. Okay, then multiply with 120 the length. Okay, now let's continue. Okay, so let's simplify this first. I'm going to add up the 90 with the 90 to get 180. 180 plus 2x. 180 plus 2x times x again times 120. Okay, so I'm going to multiply half with this and this. So the 180 will become 90. The 2x will become x, then 120. Okay, then we expand it. 90 times 120, we get 10,800 x, 120 x squared. Okay, so we got this as the volume. This is the quadratic. Okay, let's say I put it 120x plus 10,800x as a quadratic. Okay, so that is the answer for the first part, which is the part A here. Okay, now here, this figure shows another section of the freeway, which is to be constructed by cutting through a hillside. The depth of the cut is x meter. So as you can see here, you have to cut the land in this shape. And the width of the cutting at the base is 50 meter, which is here to here, 50 meter. Find the formula for the volume of earth in meter cube, which would have to be excavated to form a straight 100-meter section of the cutting. Okay, so again, you should expect these to be trapeziums in this way. Let's say I draw it out. Okay, so this is going to be a trapezium like this, and then it extends all the way back by 100 meter based on the question. Then they give us that information. Oops. Okay, so it's going to look like that. Okay, now we are given that it is 100 meter in length, so meaning that here is 100 meter, and then the height is x meter, the base is 50 meter, and okay, we need to find out the length here. Okay, so we have to look at this triangle again to find out the length here. Okay, so in order to find the length over there, we need to make use of the 65 degree. 65 degree, so how we make use of it? Let's say, for example, okay, I draw out again the shape. -65 degree, 65 degree. Okay, so they are going to form a right angle triangle in this way. So the bottom is 50 meter. So again, I'm going to add two lines. One is here, another one is here. So that you can see this is a rectangle, and hence here is also 50 meter. Same with the bottom. So this is 50 meter, the bottom is also 50 meter. Then when they come to here, we need to find this out. Okay, so to find this out, okay, this 65 degree will be useful here. Okay, so we know that the height is x, which means this is x, this is also x. Okay, so I know that this is going to be x. And I look at this right angle triangle. Then I can use trigonometry to solve this. I'm going to use tangent. Tangent 65 degree. I know tangent is basically opposite over adjacent. So the opposite is x, the adjacent is unknown. Okay, so opposite x over adjacent. Okay, now I want to find out adjacent basically. So adjacent equal to x over tangent 65 degree. So I get the adjacent. So the adjacent that I mean is actually this adjacent. This is the adjacent. Here to here is the adjacent. I get ready. And because of that, here will be the same value. That is going to be x over tangent 65. Likewise, here will be x over tangent 65 as well. Okay, so let me check whether 1 over tangent 65. Okay. I'm trying to check with calculator, and I realize that 1 over tangent 65 is a decimal. Okay, so I just leave it like that first. Okay, so all together, the whole length is 50 plus 2x over tangent 65. 2x because I add up the two sides here. So we have this, add up with this. So x plus x become 2x. Okay, so that is the length of the whole part here. The whole part. Take this value. Okay, now let's come back to the question again. So again, they want us to find the volume. Okay, so the formula, volume equal to area of trapezium multiply with length. So area of trapezium 1 over 2, add up the parallel sides, 50 plus 50 plus 2x over tangent 65, multiply with the height is x. These are the area of trapezium, the one that I put in square bracket, multiply with the length is 100. Okay, so now let's continue doing this.
Okay.
1 over 2, 50 plus 50 is 100. 2x over tangent 65 times x times 100. Okay, now we just continue with this. Okay, let's say I just multiply the half and the x and the 100, then I will get 50x. 50x 100 plus 2x over tangent 65 degree. then I multiply the 50x into both, then I will get 5000x, then 50 times 2, 100x squared over tangent 65 degree. Okay, so it look like this if we want exact form. But if I change it to decimal, okay, let's say I press calculator. If I change it to decimal, then it's going to be, of course, what am I doing is I press calculator for 100 divided by tangent 65 degree, so I get 46.63. So I'm going to write it here, 46.63 x squared plus 5000 x. Okay, so it's a quadratic form again. Okay, now as you can see, we get two quadratic forms. This is the first one. Oh, I just realized the square is missing. Okay, I add back the square here. Okay, the first form, the first answer, quadratic. This is the second form, which is also a quadratic. Okay, now let's see here. They say if x equal to 4 meter, what length of embankment could be constructed from earth taken from the cutting? Okay, so x is 4. What length of embankment? Okay, you see here. The length of embankments, of course, is going to be this one. This is the embankment, the freeway embankment. This is the embankment. Could be constructed from earth taken from the cutting. So you're going to cut here. You're going to cut the earth here, and you're going to take the earth here and put it as the embankment here. So they are asking us, how long can we do that? Right? If I take the earth here and use it to form the embankment there. Okay, so this is like an engineering question already. Okay, now let's see. We have part C here. Part C. So let's say I do it here. So let's say x equal to 4. Yeah. X equal to 4 meter. Okay, so let's see how much earth is taken from the cutting, from this cutting. Okay, from the cutting. From the cutting itself, we have to use this formula. We have to use this formula.
Hello?
Yes.
Hello?
Yes. Hello. Yeah.
So yeah, you cut out the whole time.
Oh. Okay. So what happened is x is 4 meter, and then I'm going to put 4 meter here to find out how much earth we get from this cutting. Okay, so to make it accurate, so I'm going to use this equation instead, which is the exact form. So 5000 times 4 plus 100 4 square over tangent 65 degree. Okay, so now we just need to check with calculator. 5000 times 4, 100 times 16 over tangent 65 degree. So we get 20746.09225 meter cube. Okay, so this is the volume of earth obtained, or the soil that we get, okay, from the cutting. And now we are going to use this amount of earth. Okay, this is the amount of earth that we get from the cutting. We are going to use it to form the embankment here. Okay, so the embankment, this one, is based on this formula. So we have the volume now, we have to find the length. That means we have to find, we have the volume and x is 4. X is 4. Okay, so we need to find the length. The length, okay.
Wait, so your screen has disconnected.
Oh. Okay, so we have the volume now. So this is the volume. Okay, and then we also have the formula for the embankment. But this time we have to be careful with the formula of the embankment. We can't use 120 meter anymore, because we are going to find the length actually. So let's say I call this y. Let's say we need to find y. We have volume, we have x is 4 over here, and then we are looking for the length, which is y. Okay, so I'm going to put it in this way. Okay, so I'm going to use these informations. Okay, volume equal to, okay, I changed my mind. Let's say I use the simplified version. I use the simplified version. Okay, let's say this one. It's just that I don't want the 120 here. I change it to y. The rest I can just reuse. So volume equal to 90 plus x times y. Okay, so the length 120 we don't want, we want to find out. Okay, so now I'm going to put the volume here, 2074.6.09225. The x is 4, and we are looking for y. Okay, so we just need to solve the equation here. Okay, so I just solve right hand side. 94 times 4, 376 y. Here same. Now I can get my y. I divide the 20,000 with the 376. Then I get 55.17577726. Okay, let's say I round off to 55.18 meter. Okay, so this is the length of the embankment that I'm able to form. Okay, 55.18 meter. Okay, so this one settled. Okay, question 5. 100 meter of angle steel is used to make a rectangular frame with 3 crossbar as shown in the figure. So you can see 1 crossbar, 2 and 3. So these are the flame. Okay, so if the width of the flame is x meter, so this is the width, determine an expression for L, the length of the flame in meters in terms of x. Okay, so this is x, this is L, this is x. So we have 100 meter of angle steel. Okay, so which is going to make this and this. Okay, so we want to make this flame. Okay, so now let's look at it in this way. We have L here.
Okay.
We have x, 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 and x. Okay, so altogether, the 100 meter is L plus L plus x, 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 5x, x plus x plus x plus x plus x. So which is going to be 2L plus 5x. Okay, so they want us to put L in terms of x. Okay, so we just rearrange the equation. 100 minus 5x equal to 2L. So 2L is equal to 100 minus 5x. So L is equal to, we divide by 2, 50 minus 5 over 2x. So that is the answer for first part, as they want L in terms of x. So that is A. Now we look at B. The flame is to be covered by light aluminium sheeting. That means you put aluminium here, 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 and here. If the area of this sheeting is A meters square, formulate a rule connecting A and X. Okay, so this is going to be like this, part B. So the area. So basically we know area is L multiplied with X. Then you get the area of this whole flame. Okay, so L,
Okay.
yeah, multiply with X. Okay, and we know L from the first part. Okay, we know L. We are going to substitute there to replace the L so that we can fulfill the requirement of the question. They want us to find it in terms of x only. We don't want to see the L here. Okay, so we just replace it. 50 minus 5 over 2x multiply with x again. So area equal to 50x minus 5 over 2x squared. Okay, so that is the answer for B. And let's continue with C. They say sketch a graph of A against X, stating the axis intercepts and the turning point. So we need to sketch this. We need to sketch this graph. Okay, so we have a few steps to do here. Okay, let's say I just put it in a different position. Okay, let's say I put it here, part C. So I'm going to sketch A equal to minus 5 over 2x plus 50x. I rearrange the equation a little bit. As you can see, the power 2 term I put in front, the x term I put at the back. Okay, so to sketch the graph, we want the axis intercepts. So to find the axis intercepts, we let's say I want to find the A-intercept. A-intercept, I have to let x equal to 0. When I let x equal to 0, so imagine I put 0 here, this whole term disappear, becomes 0. I put 0 here, this whole term disappear as well, becomes 0. So A is equal to 0. Okay, A is equal to 0. And that is the intercept. Now I want to find the x-intercept. So I have to let A equal to 0. Okay, I just realized I forgot to put square here, so the square is missing. I put it back, the square. Okay, now 0 equal to minus 5 over 2x squared plus 50x. Okay, so we need to find x from here. So let's say I shift everything to the right. 5 over 2x squared minus 50x equal to 0. So I factorize the x. 5 over 2x minus 50. Okay, now for the first factor, x is equal to 0. For the second one, we let the whole thing equal to 0.
Okay.
Yeah, then we look for x 100 over 520. Okay, so we have 0 and 20 as the X intercept. We have two X intercepts here. And
Yeah.
turning point. Okay, turning point we need to do completing the square. Turning point. Okay, so A equal to minus 5 over 2x squared plus 50x. So to do completing the square, you have to make sure the coefficient of x squared is factorized. So I'm going to factorize minus 5 over 2. Then I will have x squared for the first term. For the second term, we just take 50 divided by negative 5 over 2 to see what remains. So 50 divided by negative 5 over 2, I get negative 20. Negative 20 x. Okay, so after factorizing, I get this. Now we continue completing the square in this way. X squared minus 20x. Our b is negative 20. This is our b.
Okay.
So we have to put b over 2 square. Negative 20 over 2 square. Negative 20 over 2 square. Okay, then we continue. Okay, so we count it here. Negative 20 over 2 is negative 10. Negative 10 you square is 100. So we get 100 minus 100. Negative 5 over 2. Okay, now for the first three terms, we need to factorize them. Okay, to factorize, we get x minus x minus 10 square. Okay, so of course, if you are wondering how I factorize, then you can see at the side here, x times x square. You think of two same numbers multiply and get 100, and when you add them up, you get negative 20. So that is going to be negative 10 times negative 10, you get positive 100. Cross multiply, negative 10x, negative 10x, add them up, negative 20x. Okay, so then we get the factors as x minus 10 and x minus 10. So that's why x minus 10 square, for the first three terms, we factorize it to x minus 10 square. And after that, minus 100, I just write back. Minus 100. Okay, now I multiply this with this and multiply this with that. Then I get x minus 10 square plus 100 times 5 over 2, 250. Okay, so I managed to do completing the square, and I will get the turning point in this way. So you just need to let this bracket equal to 0. X minus 10 equal to 0, x equal to 10. This is going to be your y, 250. So we have x and y, they are the turning point. For this case, the 10 to 50 is actually a maximum point, because this is a negative value. Negative value, then this is maximum. Maximum point. So the graph is going to be like this. And now let's sketch the graph. Okay, so we sketch the graph. Let's say I sketch it here. And 250. Then we have the axis intercept 0, 0. And the other intercept is 20. So we have A versus X. Okay, so this is the graph. So I don't extend more here because I know the area cannot be negative, so I don't want to extend to the negative area, so I just stop at this point. I don't extend down, and here likewise I don't extend, as I know area cannot be negative, x cannot be negative as well, so I don't extend to the negative value of x. Okay, now let's see part D then. What is the maximum area and the values of x which give this area? Okay, maximum area, so we can find it from here. Part D, maximum area, we can just look at the maximum point, 250. This is the maximum area. Okay, 250 250 meters square. And then they also ask for the x value, so x is this x value from the turning point here, 10 meter, 10 meter, and this question finish.